Hello, little koala bears. Welcome to lesson 4.2, similar triangles. What we're going to be talking about today is a really important topic in mathematics. It's one of those that has a lot of applications in real life. In fact, I would dare to say it changed my life. Okay, that's a lie. It didn't change my life, but it is still very important. So I just want you to pay attention and take it all in because this is a biggie. So what are similar triangles? Well, I'm going to go back a second. Before we talk about similar triangles, last unit we talked about congruent triangles. And congruent triangles are triangles that are exactly the same shape and size. Well, similar triangles are similar if they are the same shape. All right, they're the same shape, but they have a different size. All right, so that's the difference between congruent because they are still the same shape, but their size are different, so they can't be congruent. All right, so we have two pairs of triangles down here. Two of them are similar, two of them are not similar. Take a minute, pause the video, and figure out which are the similar ones and which are the not similar ones. All right, pause the video. I said pause it and figure it out. All right, now that you're back, let's talk about it. All right, well, if you look at these two triangles, they are exactly the same shape, right? They are both these isosceles-looking triangles, but they are different sizes. So these would be similar, all right, because they knock off our boxes. They are different sizes and they are the same shape. So those would be similar. Now if you look over here, these two, while they are different sizes, they are definitely not the same shape. All right? So this is not similar. And I know what you're thinking, these are triangles, isn't that the same shape? By same shape, I mean it has exactly, they look exactly the same, just bigger and smaller versions of themselves. Like Honey, I Shrunk the Kids, one got smaller. So these are different sizes, but it is not the same shape. So it is not similar. So let's talk about the properties of similar triangles. There's two that we really have to be aware of, okay? If triangles are similar, we know two things. The first thing we know is that all angles are, and that's alliteration right there for you English people, congruent, and now it's not. Or maybe it is. I don't know. Ask Mr. Ayers. All angles are congruent. So in this case, we know that all three angles in this triangle, ROB, are exactly the same as all the triangles in FAT. Now, just like in congruent triangles, the order of these statements matters. So I know R is congruent to F. R is congruent to F. We can mark that. All right. We know O is congruent to A. O is congruent to A. This is just like in congruent triangles. The order of these statements matters. And we know B is congruent to T. And we'll just mark that over here. All right. So remember, just like we did in congruent triangles, the order matters in these statements. All right. Now I should probably say this also. What's that little squiggle right there? That little squiggle means similar to. That's the symbol for similar. All right. So that says Rob is similar to Fat. I have a friend named Rob, and I just called him Fat. Alright, so anyway, all the angles are congruent. Now, the sides are not congruent, but all the sides are actually have the same ratio. Alright, all sides have the same ratio. And what does that mean? Well, let's check it out. So, right here, let me go back to my statement right here. All right, and just do a little erasing. So just like in congruent triangles, I know that RO is going to be proportional to FA. Those are the corresponding sides. So RO is proportional to FA. All right, and the size of RO is 10, and the size of FA is 5. So 10 over 5 is equal to 2. So the ratio of RO to FA is 2. Now the same thing goes for OB to AT. So the length of OB is 12 and the length of AT is 6. Oh, sorry. And so that's 12 over 6, and that is, once again, 12 divided by 6 is 2. And then finally, we have our last ratio, which is RB to FT, which is this side right here, RB to FT. So the ratio of RB to FT is 8 2, 4. And look at that, 8 divided by 4 is 2. So the ratio of the sides will always be the same. All three corresponding sides, that ratio is always the same. If I had different numbers here, if those ratios were different, it would not be the same shape. They would not be similar triangles. So the way to write that out, I know the ratio of RO to FA is equal to the ratio of OB to AT, which is equal to the ratio of RB to FT. All right? So they all have the same ratio. All my ratios of the sides are the same. That is a key component of similarity. So we can use these properties that we just learned to solve some problems about triangles. Let me show you how. Triangle BIG is similar to triangle LUV. What is the length of UV? All right, UV is right here. So since I'm looking for UV, let's just put an X there. All right, so I know exactly what I'm looking for. I'm looking for UV. Well, based on what we just learned, all right, I know that the ratio of, let's say, BG, which is the last two letters here, to LV, which is the last two letters here, so this ratio is going to be the same as the ratio as IG, which is right here, is to UV, all right, which is right here. I know those ratios will be the same. And that's going to help me solve for X, and I'll show you how. So first, this is what you do. We're going to do the bigger triangle on top, we're going to set up a ratio. So always put the bigger triangle on top. So I'm going to say BG's, this is my bigger triangle, so the length of BG is going to be proportional to the length of LV, all right? And that's going to be equal to the ratio of my bigger triangle. Always put the bigger triangle on top, IG, to UV. All right? Those ratios will be the same. Well, now let's just plug in our numbers. All right? So I know if BG is 10, all right, and LV is 5, that's going to be equal to, well, IG, bigger triangle on top, is 14, is to UV, which is X. All right, I'm just plugging in my numbers now. Now we cross multiply like we learned in the last lesson. That is 10x is equal to, that is 70. Divide both sides by 10. Oh, I'm running out of room here. And I get x is equal to 7. So UV is equal to 7. All right, see, you just have to set up these ratios. Now, I'm going to emphasize, always put the length of the bigger triangles on top so you don't get mixed up. The bigger triangle, always put it on top, okay? It just keeps things honest and simple that way. Put the bigger triangle on top on both sides of the ratio. All right, let's try this again, all right? I know that triangle ABC is similar to triangle DEF. Find the length of CB, so I'm going to put an X there because that's what I'm looking for. If AC is 12, let's put that there, DF is 9, and FE is 14. All right? Now, first thing we do, let's find out which sides are proportional, okay? Well, I know that AC, that's my last two, is going to be proportional to DF. All right? So AC is going to be proportional to DF. All right? And then I also know that, let's see, my bigger triangle is this one. So CB, which is these two, CB is going to be proportional to EF. All right. So I set my proportional sides. I put my bigger triangle on top on both cases. All right. And now, well, let's just plug in the numbers that we have. So I could do 12 is 2. Let's see, AC is 12, DF is 9, as, well, CB is X, is to EF is 14. All right, let's cross multiply that. We get 9X is equal to 168. Divide both sides by 9, and we get X is equal to, let's do 9 divided by 168, and that is 18.666 going on forever. Now you see, got a fraction, didn't freak out. It's okay. Sometimes you just get fractions. So our CB is going to be equal to 18.666 bar because it goes on forever. Okay, let's keep trying it. Let's see if we got this. So here we know triangle XWV, which is this smaller triangle right here, is similar to triangle XYZ, which is the bigger triangle. All right, this whole guy right here. All right. If XW is 4, so we have this part right here, XW is 4, and WY, which is right here, is 8, and WV is 5, what is the length of YZ? And that's at the bottom here, so that's going to be our X. Well, what we need to do is set up some proportions, right? So what I want to do is find the corresponding lengths. So I know, let's say that for my bigger triangle, which is right here, that XY is proportional to, if that's the bigger one, XW, right? Those are the first two in both of them. All right, those are proportional. I also know that in my bigger triangle, YZ is proportional to WV. Okay? Well, now I just have to plug in what I have, okay? So first, let's take a look. I know that YZ is X and WV is 5. All right? Those are given to us. I also know that XW is 4. Now the only challenging part here is figuring out what is XY, because that is not given to us. We know that WY is 8, so not to be confused with XY. We want to know the length of this whole side right here. To get that whole side, you actually have to add these two parts. If this part is 4 and this part is 8, if you add them together, you get the whole side. So that is 12. All right? And now we have our proportion. All right? So 12 is equal to the whole length of XY. So now we cross multiply, and 12 times 5 is 60. All right, I'm just moving it over here. And 4 times x is 4x. We divide both sides by 4. We get x is equal to 60 divided by 4 is 15. All right, so our bottom is equal to 15. All right, so remember, you have to add those two parts to get the whole length, and that should make that question a lot easier. Finally, we're going to talk about the perimeter of similar triangles. If two triangles are similar, the ratio of the perimeters is equal to the ratio of the sides. What does that even mean? Well, let's look at this question right here. We'll try to figure this out. Triangle ABC is similar to triangle DEF. Find the perimeter of triangle DEF. Well, okay. So if you're thinking about this for a second, you could probably just find your missing side lengths here setting up proportions. I could find the length of EF and DF by setting up my proportions. And once I have all three sides, I can find the perimeter of DEF. All right, if I find these two sides. That's one way to do it. That's the long way. All right, but I would like you to do that. So please pause the video. Find the length of EF and DF by setting up your ratios. So that would look something like this. 16 is to 4 as 12 is to x. All right, and also find out what DF would be. So that would be 16 is to 4 as 24 is to y. Find out what those two sides are, all right, and see what they are. This is the first way you can do it. You can just find the two sides and see what you get. Take a minute, do it, come back in a second. So if you did this correctly, you should have gotten x is equal to 3 and y is equal to 6. So we know the perimeter of our smaller triangle right here is going to be equal to 4 plus 3 plus 6, which is equal to 13. So this perimeter is 13. All right, that's one way to do it. All right, a little bit of a time saver, and an easier way to do this is you could actually set up the ratio of your sides and set that equal to the ratio of the perimeters. And what I mean is this. So the ratio of the sides, once ago, and is 16 is to 4. So our bigger triangle has a side length of 16, and the ratio of our smaller side is 4. All right. Now this ratio is going to be equal to the ratio of the perimeters. So if I find the perimeter of our triangle here, where I know all the sides, so 16 plus 12 plus 24, which is equal to, let's see, that's 36 plus 16, 52. that will be equal to the ratio of the perimeter of my bigger triangle is to the smaller triangle. And since I'm looking for the perimeter of my smaller triangle, I could just put x. All right, well now we cross multiply. We get 16x is equal to 208. Divide both sides by 16, and we get x is equal to 208 divided by. Well, look at that. We also get 13. So that's just an easier way to do these problems, right? You could just set up the perimeter. So the ratio of the sides is equal to the ratio of the perimeters. All right, bigger perimeter over the small perimeter. We always do bigger over smaller. Well, let's see if that can help us with this problem. Triangle MNO is similar to XYZ. Now, if you start reading a problem, there's no picture there, you've got to draw that yourself. So MNO, MNO, and we have XYZ. All right. The lengths of the sides of MNO are 20, 14, and 18. All right. Does it matter where? No, because it doesn't tell you. The longest side XYZ is 10. What is the perimeter of MNO? Well, if the longest side here is 20, so we should put our 10 over here. Remember, they should correspond to each other. So if the longest side is on the bottom, the longest side of XYZ should also be on the bottom. All right, those are the only things that you should be worrying about. So now we want to find the perimeter of triangle MNO. Now, once again, we could just find the missing sides by setting up our ratios, or we could do it this way. The ratio of our sides of our similar triangles, 20 is to 10, will be equal to the ratio of our perimeters. So our bigger perimeter is 20 plus 14 plus 18. 20 plus 14 plus 18. That's 20 plus, let's see, that's 32. So once again, it's 52. And so our smaller perimeter, we don't know, is x. You cross multiply those and you get 20x is equal to 520. Divide both sides by 20. We get x is equal to 26. All right, that is the perimeter of our smaller triangle. All right, that's how it's done, guys. Good luck, and remember, tell your grandma you love her, because she's actually kind of like your mother too.